this section, we're going to start talking about calculators. You have several different keys that could be on your calculators for raising things to a power, either x to the y, or maybe your calculator has y to the x. Some of you have an up caret key instead. Let's take a look at a couple of calculators here. I have a Texas Instruments graphing calculator here, a TI-83 in front of me, and notice that it has an up caret key on it to use for its raising to a power. I also have in front of me here a Texas Instruments solar calculator, and it has a key with a y to the x button on it. Now some of the sharp calculators will have x to the y. It just depends on your calculator. Now also we have to pay attention to whether your calculator works in a forward direction or what I call a backwards direction. There are two logarithms keys. There is a key that actually says log log on it, and there should be a key on your calculator that has an ln on it. And above these keys that you have to hit the second function to get up to should be written 10 to the x and e to the x, because the common logarithm log has base 10 and the natural logarithm has base e, where e is a number we're going to get used to using. So again, this is called the common log and the other one is called the natural log. Now what is this number e? Well, by definition we can say as x approaches infinity, the expression 1 plus 1 over x all to the x power approaches the number e. You'll just have to get used to that. Just right now, think of it as just another irrational number like pi. This is going to be approximately 2.71 that we're going to be dealing with. Let's do a few calculations on your calculator. I don't think anyone's going to have trouble raising a number to a power, so let's just verify that you can get 4.9174. Please pause this video if you need to check this. Now for e, which is e to the first power, the value is 2.71828. Now some of you might have what I call a backwards calculator. The e to the x on my calculator is above the natural log, and if I just hit that button and go second e to the x, oops, I get 1. What happened there? I actually took e to the 0 power. I have to enter the power first on my calculator and then the e. Now that I've got 1 on the screen, if I hit second e to the x, it'll give me e to the first power, and there's the 2.71828 that I'm looking for. So if I mention a backwards calculator, that's where you enter the power first. Let's move to this next problem. Because no base is written, it is assumed to be base 10 using the common log. Some calculators you're going to hit your log button, and if log shows up on the screen, then you'll type in 4387, close parentheses, and hit equals. On my calculator, I have to type the 4387 first. 4387, then hit my log button, and now I can get that value coming out, which is 3.6422. And if you think about it, you know that 10 to the second is 100, 10 to the third is 1,000, 10 to the fourth is 10,000. Well, that's between 1,000 and 10,000, so we would expect the value of the logarithm to be between 3 and 4 as it is. Now, the natural log of 317. You're either going to hit the natural log button and 317, or you're going to hit the 317 and then hit your natural log after that. Check your calculator. You should get 5.7589. Likewise, e raised to this decimal power, depends on whether you have to type the e in first or the power first, you should get approximately 43.8160. Now I'm going 4 decimal places or 5 decimal places out on each of these problems, and that is kind of an important thing to do in this chapter because the accuracy of these logarithm and exponential equations is very important. So go at least 4 or 5 places out when you write your solutions, your final solutions down, unless the directions tell you otherwise. Now if you have a log with a base other then common log base 10 or base e. Then you've got to change your tactics a little bit and use what's called the change of base formula, which I have written down here beneath this problem. Log base unknown base b of n is the log of n over the log of b. So in this problem up above, this will become the log of 56 divided by the log of 7. Now I can treat those as common logs or natural logs. I can choose any base I want to do that with. On my backwards calculator, I have to type in 56 log divided by 7 log. If you have a forward calculator, you'll probably have no trouble evaluating this and finding out that the expression is approximately equal to 2.06862. And down at the bottom of the page, I have another one here where we're going to write this as the log of 45 divided by the log of 5. Do that directly on our calculator and get approximately 2.3652. Please stop and make sure that you can get these calculations correct on the calculator that you are working with.